And the next topic is not too difficult. Again, like with the first topic, there's a process. There's steps that I'd like to go through for doing the questions. So in the first lesson we had I, E, S and F. Okay. In this lesson here we have a similar idea for steps. Still trigonometry. Now we're looking at graphs. So if I said to you, you know, what was the one we had earlier? Something like 3 sine x minus 2 or something like this. Well, that's like me saying, okay, consider the graph y equals 3 sine x minus 2. If I want to know when it's equal to 0, that means I'm trying to find the roots. So we can think about this as a problem of trying to find roots on a graph as well. But of course that means we need to know what the graph looks like. So let's have a look at the different graphs we can have here. So the first one, so these are, lesson now is about the trigonometry graphs. So the first one is just a simple sine x. It goes from 0 degrees to 360 degrees. It goes up to 1 and down to minus 1. X here and Y here. And the shape looks like this, where this point here is 180, this one's 90, this one's 270. So this is what sine x looks like as a graph. And not only that, this graph is periodic, meaning if I continue past 360, it just repeats itself. Likewise, if I go before 0, it just repeats itself. So it's really, this is the interesting part because this is one period. Anyways, draw this one now. This is sine x. No, draw it. You're out of paper? Get more paper. Okay. So we'll look at cos x next. Adnan, would you like me to kick you out? Well, put the football game away. You're still looking at it. Okay, because nobody sits at the back in maths class going, should have scored that. Right, so do you want me to kick you out? No, so put it away. I don't want your phone on your desk because I don't trust you now. Okay? Right, do you have sine x there? Yep, right, so let's have a look at cos x. Again, we go from 0 to 360, and again from 1 to minus 1. But the difference with cos is only where it starts. Sine started in the middle, but cos starts at the top, at 1. And it goes down to the minus 1, and then back up to 1 for the end. And just like with sine, it repeats itself as well. But it's the middle part we care about. And this here is 180, and this is 90, and this is 270.
That one? Oh.
This is a 1 minus 1. Okay, did you write this down? Yeah, you got this? Yeah. And the next one then is tan x. Then after we do tan x, we'll look at more complicated graphs. I should tell you that in the syllabus it says sine, cos and tan, but I've never seen them ask for a tan graph in the exam. So in total there's been 36 exams, I think. Well, actually maybe even more than 36. Anyways, they've never asked for a tan x, I think because maybe it's a little bit too difficult, but I'll draw it here for you anyways. So this is tan x. Um, 90, 180, 270 and 360, and this is x and this is y. Yeah, so it's kind of hard to see, but what happens here is the tan goes through 0 from minus infinity, and then it shoots back up to infinity at 90. That's an 8 at infinity here. And then when it passes 90, it comes back up from minus infinity, hits through 180 again, and then hits back up to infinity at 270. And again, once it passes 270, it's coming up from minus infinity, and then, oh, hang on, if I got this right, 91, no, sorry, I've done something, 90, yeah, no, that's it, yeah, it comes up from minus infinity again, and then it goes through 360, and then whatever the next one is, 450, is the next time it hits up to infinity. So the tan graph is these what are called asymptotes, but you don't need to know that. They're these like vertical lines. Now they're not lines, there is a bit of a curve. They're a little bit like a cubic, kind of has this cubic shape to them. But the big difference is that they shoot up to infinity and minus infinity at key points. Now I've done something. That 90, 270, and the next one is like 400 and something. More important is where the roots are. So the roots are at 0, 180, and 360. So every 180 degrees is a new root, and it's the same backwards as well. So there's a root here, and then there's a root here as well. So it keeps repeating like this. Try to draw this one. It's a little bit difficult, but the good news is it's not been on the exam. They focus on sine and cos. Okay. All right, do you have this? Yep, right. Now let's just add some information to the graph. So for example, if I have a number that multiplies the sign, like for example a sine x, does anybody know how the graph changes? Like if I had something like y equals 2 sine x. What changes? The vertical changes. How exactly? Yeah, what's the verb? Expand or stretch. In other words, vertically it's 2 times bigger. So if sine x was originally like this, then 2 sine x or 3 sine x, it looks like it's stretched. So originally this goes from 1 to minus 1, and now it will go to 2 and minus 2. Or if it's an A and minus a. So it gets stretched like this. So that's the first rule, I suppose. If you can make note of this, number 1 then. Number 2 next. Okay. No surprise here that the next one will be if we multiply the x, like sine bx. So for example, if it was sine 2x, what happens here? Does anybody know? Oh, and of course, this is true for cos and tan. Sine bx, what happens? Describe with the graph, the change in the shape of the graph. Smaller, yeah. If it was sine 2x, then the graph is half the size. It contracts. So basically, instead of finishing at 360, where would it finish at? 180 if it was 2. So in general, it would be 360 divided by 2, and in this case, b. So the b shrinks it down horizontally. Be careful with that one. Okay, next one now.
I don't understand how that would apply.
Yeah, if you were to test it out on your calculator, for example, if I use x as 180, what's 2 times 180? 360. So by having the 2 on the x, you make the graph move faster through its cycle. So for example, if I had 10x, when would the sign get to the end? At 36. So the b makes the graph run through its cycle faster. It speeds up the x. You can think about it like this. Yeah. The next one now is sine x minus c. We usually write it as a minus. So what happens? Graph gets translated, moved to the right. Yeah, so if it was like this, it's now being moved to the right c units. Just shifted along to the right. Yeah. Okay, you have this? Did you write this down? Yes. Okay, 4. Last of the possibilities is sine x plus d at the end here. Moves the d units up. So if the graph is like this, starting at 0, for example, it just gets moved up d units. Minus y? Oh yeah, yes. We'll have a look at that now actually. Can I scroll down? Yeah. So the last one, which I think we kind of talked about already in exponential and logs, is if we have a minus on an x or a y. So for example, if I just have y minus something, doesn't matter if it's sine, cos, tan, log, e, whatever. What happens when you put a minus on your graph? Yeah, like we saw this with the quadratic. It gets flipped upside down. Yeah. And then the other possibility, whoops. Yeah, if you put the minus on the x. So for example, if it was something like sine of minus x. Now actually you don't see anything happening. Oh no, you do actually. It's hard to see, but you just flip it around. So in this case, let me see. Oh, yeah, it would look like this when I flip it around then. So, this gets flipped over to here. This mirror image. So these are the possibilities. What we need to do now is how to combine them if we had several happening at once. That's the tricky one. Okay. Can I scroll down? Not yet? Okay.
Could you just scroll up? I missed something.
Alright, there.
Before. Oh, there it is. So the difference in 6 is where the little lump is? Yes, no.
The 6, the minus is on the x, it gets flipped around. We have to know it's 6, isn't it?
Yeah.
Yeah. Yeah. Which number? 2, yeah? Like x over 2? Yeah, so then it would be the opposite, because what would happen is it would be 360 over a half, which is 720. So if you had a half x, it would actually make it longer. Yeah? Oh my goodness. This is when you had no paper, isn't it? Yeah, right, hurry up, hurry up. I'll give you a few seconds here. Okay, we'll have a look at an example where we have to put these together. Can I scroll down? Yeah? Okay. So we'll say we want to make the graph y equals 2 cos 2x plus
1.
30
Okay, good.
plus 1. And we want to make the graph here of this one. So, what's the A for this one? 2. And the B? B? What's the B? No, come on, what's the B? Look at your rules. 2. What's the D? The D? 1. And what's the C? 30? Or is it minus 30? Yeah, so we usually write the C as like a minus C, so this is like minus 30, but I mean you don't have to, as long as you remember that when you looking at the graph, positive values mean you move it to the left and negative values would mean you move it to the right, so don't worry too much about the plus or the minus here. But it's actually not 30, and we have to be very careful. It's 15. Yeah. Now please watch very carefully. The first thing I should do is take the 2 out. 2, and let me put it in a different colour here. X plus 15 plus 1. Now this is the A because it multiplies the cos, right? This is the D because you add it at the end. Yes? This is the B because you multiply it by the angle. But if it is the B, it has to multiply the entire angle, not just part of the angle. So this is why I took the 2 out, because I must have this. The B must multiply all of the angle. Back here, where's it gone? This B is the number that multiplies all of the angle, not part of the angle, all of the angle. So this is the reason why I had to factor it here. So this is the C, it's 15. And remember, the positive means I move the graph to the left. Right, let's make the graph now that we have the A, the B, the C, and the D. So step 1 is get the A, the B, the C, and the D. Step 2, I like to make a table. So let me just put a table here. No, not that type of table. Right, so what we have here is start, end, min and max. Okay. Right. So for costs, it usually starts at 0 and ends at 360. And what's the lowest point on the graph? What value is it? -1, and the maximum is 1. And then what we're going to do is we're going to go through A, B, C, D to see how these change. So firstly the A. What will the A affect? The start, the end, the min or the max? Min and max. So these are unaffected and these become -2 and +2. Done. Okay. The B, what affect, or what does the B affect? The start and the end, or rather the end here. So it doesn't end at 360 now. Where will it end? 180 divided by 2. Okay, so now we've taken care of the B. That's done. The C moves it to the left 15. So what does that affect? The start and the end. Now this starts at -15 and ends at 165, isn't it? Yeah, 165. Are these affected? No. And lastly, the D, what does that affect? The min and max. How so? Up 1, isn't it? So now what is the minimum? -1, and the maximum? 3. So this was what you will need to help you make the graph. So first write this table down. And then once we have this table, I'll show you how to use this table to make the graph. Again, has anybody seen these types of problems in high school, making the graphs of this? And have you done it this way? No. Did you use in a table like this?
Yeah.
Well, they stole my idea. This is my idea. I find the table is very useful here. Very useful for making the graph. Okay, do you have this table now? Yes? Can I scroll down? Yes? Okay. Guys, look up now. Nathan, look up. Right, so I'll make the graph nice and big here. So we'll have, this is the y-axis, and then this is the x-axis. Now I need to go up to 3. So I'll break this up in here, 1, 2, 3. And then this will be -1, -2, -3. Now, I start at -15 and I'm going to 165. So maybe I should go up in 15s, like this would be -15. Or I could go up in 30s, I think would be more convenient. So if this is -30 here, then this one here would be -15. If this one here is, that's not quite right scale. Here I'll make 30. This one 60, 90, 120, 150, 180 here at the end. These are going up in 30s. So that's 60, 90, 120, 150, and then 180. And in the middles are 15. So this is 15, 15. This one here be 45, and so on. So middle values will be 15s. Right, so now that I've made my x and y axis, I can now start to put in the graph. So what I do first is I look at where the graph starts. It starts at minus 15, which is here. And if you're doing this in your notebook or the exam, use a very, very light pencil. So I'll use a green color here and draw a straight line down through the minus 15. And again, in your exam, make a light mark with the pencil. I finish at 165. Let me see, that would be here, this one. Again, with a light pencil, go straight through 165. Minus 1 is down here. Again, with a straight pencil, light pencil, go through minus 1. And then 3 is at the top. So with a light pencil, go through 3. And it's like this. So first step is to make a box. This will help you draw the curve. It needs to fit in this box. The next step is to break the box into 4 equal quarters. So if I start at minus 1 and go to 3, where should I split this in half? At 1. So again, light pencil, split it at 1. And if I'm going from minus 15 to 165, where should I split it? It should be 75? 75 is in the middle, I think. Now, if you're not sure, you can just add the 2 and divide by 2, but it'll be 75. Yeah? So, straight through 75. Now, it might be a bit hard, but can you see that I have a box here, a box here, a box here, and a box here? Can you see those 4? Right. So now we're ready to draw the graph. Are we looking at sine or cos? So do we start at the top or do we start in the middle for cos? We start at the top, and do we go up or down? We go down. So what we do now in blue, the answer, we start at the top, we go down, and then we finish back at the top. So we tried to draw the cos graph into our boxes that we made. And then copy, paste. Copy, paste. So it continues like this. So if you had a ruler, what you could do is you could measure this with your ruler and make the boxes out here. You know what I mean? Like measure the same boxes out. So you'll get the cos graph repeating left and right. So the key is, once you get the first one done, you can just measure these boxes to the left and to the right, and you can make more either side. Yep?
When you're finding like the middle answer,
Yeah.
isn't it 150 minus
150.
minus 3?
Oh, sorry, yeah. Did I say something different? Is it not 75? No, it's 165. 165 minus 15 divided by 2. 90. But it's 90 in from the start. 90 units in from here. So if I do minus 15 plus 90, I get 75. Yeah, I know, it's because we're measuring from minus 15. It's what throws it off a bit. Okay. And then it continues down as well here. But really, like I said, this is the key one to get right. Now, I'm going to draw this graph just to make sure it's right. So, can you just call out the formula, please? What was it? Y equals 2 cos 2x degrees plus, well, give me the original, 2x plus 30, was it? Plus 1. So I'll graph this, and then I need to zoom out. So you can see, if you were to, if you look at my graph, it starts a little bit underneath 3, that is not a nice graph. It comes under the tree as it goes down and then goes back up because it starts at tree. So it goes under the tree and then at around about, I don't know, 30, 40 degrees, it goes under 1 and then, no, I did that, no, it's my mistake. What's my mistake? I didn't go all the way down. Yeah, so let's try that again. Oh, so ugly. Right, that's a bit better. So down here at, what angle is that? That's in 75, it's at the lowest point. And can you see 75 would be here? It's at the lowest point. Where does it cross the axis at? A little bit before 50 and a little bit after 100. So there's 50, it's before 50, and this is 115. So here is about 100. So again, a little bit after 100. When does it finish at 165? It's back at 3. Can you see that here? So let me see. There's about 165, and you can see it's back at 3. So I know my graph is ugly, but it actually matches perfectly the point that you're looking for. And again, do you know what I mean when I say with your ruler? What you would do in the answer book is you would measure these 4 boxes, how big they are, and then literally redraw it here and make the 4 boxes again. And then you can draw it in the new 4 boxes. Yes? Well, it depends on the question. So in my worksheet, I didn't specify how wide to make the graph. In the exam, they will. They'll give you how far out to go on the x-axis. So, for example, if this was an exam question and it said go from 0 to 180, I'm good because I've gone a little bit past 0 on the x, and I'm not quite at 180, so I would need to make sure I just continue this on a little bit more to get it. Yeah, question there?
Yeah, if we're going to work in the example, we need like a vector curve or something.
Which curve?
Or we suggest freehand or...
Oh yeah, so in other words, how freehand can it be and how precise does it need to be, is it? Yeah. In the exam they would want this freehand, which doesn't mean it can be a mess. It just means what they don't want is these questions are sketches. So I don't even think they would expect you to do it on graph paper. Because in the exam the verb sketch means you can do it in your answer book. Does anyone know what the verb is when they want you to do it on graph paper?
Yeah.
True. And plot. Yeah. So this is often a sketch question, which means you can do it in your normal book, answer book, and then draw it in then freehand then.
Is there any situation like when you have
like a cosine?
Sine, cosine.
But on graph paper? No, the graph paper questions when they do ask you to graph or plot, they tend to be linear, quadratic, and cubic. I've never seen them ask you to plot a trigonometry function.
Well, it's not like a cubic graph.
Yeah. It goes up, down, and back up. Yeah, they can ask you to sketch it.
In that case, we can't use freehand for that.
Oh, they can. Just you need to, on the graph paper, you need to find some points, usually key points like the roots and the intercept and the vertices, and then just freehand draw through them. I know on graph paper it feels like, actually in biology I've done graphs. And does column get you to hand draw between the points or to use a ruler between the points? Hand draw. Yeah, this is the same for maths then. Yeah. No, this is better for you because it means that you won't be, no, I know, yeah, there's wonderful instruments for beautiful graphs, but for the exam, as long as it doesn't look like a complete mess and it's, reasonable, you'll get the full marks. it's not going to cost you a mark if, you know, it's not a beautiful cubic. Once it goes up, down and up, it's fine then. Yeah? Okay. So, for your homework, for this one, again, if you can do a sine, a cos, and a tan graph, one of each, a sine, a cos, and a tan. Leave the tan one till the end, that would be the more difficult one. For the exam, you should definitely be able to do a sine and a cos. This is a common exam question in section B.
So just do one sine, one cos.
And one tan is good.
And
Try it.
oh, we're going to do it before.
Oh yes.